In this video, we're going to look at quadratic-like equations. These are equations that technically aren't quadratic, but they have the same structure as a quadratic equation, and so can be solved using the same methods that we use for quadratic equations. In order to achieve this, we will use substitution to literally change the equation into a quadratic equation. Once we have it as a quadratic equation, we will solve it, either using factoring or the quadratic formula. And then once we've solved it, we will unsubstitute. We'll go back to the original variable that we started with. And oftentimes, once you do that, you'll have to solve for the original variable. So you kind of have to, you're going to create a quadratic equation with a new variable, solve for the new variable, then replace the new variable with your old variable, and then solve for the old variable to get your final answer. So I know that might sound a little bit confusing, but let's go ahead and try an example, see if we can make sense of it. All right, so we have x to the fourth power minus 12x squared plus 27 equals 0. So you can see that this has a very quadratic-like structure. There's three terms, just like quadratic equations have, right? ax squared plus bx plus c. But this isn't technically quadratic because we have x to the fourth power instead of x to the second power. However, we can create this, we can change it into a quadratic equation, would be a good way to say it, by replacing the x variable with a new variable in such a way that it comes out quadratic. And the way we're going to make that happen is, I don't know, there's a couple ways I try to explain this. One way is, what I would like to see here for the middle term is not x to the second power. That's not quadratic. For it to be quadratic, this needs to be a variable to the first power instead. That's what I would like to see for it to be a quadratic equation. So I'm just going to replace it. I'm going to cover that up, replace the x squared with a new variable that will just be to the first power. And I usually like to use w. So I'm replacing x squared with a w. Now, once I've made that choice, that's the only thing w is allowed to replace. W cannot replace anything else other than another x squared. Thankfully, I can create another one over here by rewriting x to the fourth power. I can rewrite this as x squared to the second power. And by having the x squared there, we can again make the same substitution. I'm going to replace the x squared with a w. So notice I'm being consistent here with my choice. In both cases, it's x squared that's getting replaced by a w. So I'll copy everything else down. So this power of 2 gets copied down, so I get w squared. We have the minus sign. Oops, I got a little bit carried away with that minus sign. Let's leave myself a little bit of space for the 12 that has to get copied down, and then the plus 27 and the equals 0. And so once we've made those replacements, we end up with this new equation with this new variable, w squared minus 12w plus 27 equals 0. And this is a quadratic equation now because the highest power of the variable is 2. So I will solve this as a quadratic equation. We'll do this by factoring. But again, if you weren't sure how to factor it, you could use the quadratic formula. We want to find two numbers that multiply to 27, add to negative 12. So two numbers that will do that are negative 9 and negative 3. So this will factor as w minus 9 times w minus 3. We'll continue the process of solving this equation. Now that we factored it, we'll set each factor equal to 0. So we get w minus 9 equals 0. We get w minus 3 equals 0. And then solve for w by adding, in this case, 9 to both sides. And we get w is equal to 9. And adding 3 to both sides here gives me w equals 3. So we solved the equation, but we solved it for the new variable that we invented, right? This problem did not have a w in it. That was our invention. We introduced that to the problem. So we have our solution for w, but what we really need to find is our solution for x, the original variable. So here's where the unsubstituting part comes in. I'm done with the new variable that I introduced. I'm done with w. I'm going to remove that from the problem and put the original variable back. And I'm going to follow the same choice I did here. W took the place of x squared, and so x squared will take the place of w, right? So I'm going to take the w back away, and when I remove the w, it gets replaced by x squared, just like we did up here, right? So this goes both directions. W takes the place of x squared, and x squared is going to take the place of w. So we do the same thing in both spots, right? This w is also going to get replaced by x squared. Right? It's not really getting replaced by x squared. We're just removing the w, and x squared is going back where it originally was supposed to be. All right. Now that I've taken the w back out of my problem, I have x back in my problem, but it's not solved for x anymore because it's x squared. So we need to finish the problem by solving for x here by canceling out the power of 2. So you guys knew what to do, I'm sure. Take the square root of both sides, and we'll do that for both of these. And so we end up getting x equals 3. And I'm kind of pausing there because hopefully you remembered what else should go with that. Since we took the square root of both sides, we need to put a plus or minus there. And the same thing on this one, right? On this one right here, we're going to get x equals, it's the square root of 3, but because we took the square root of both sides, it's going to be plus or minus. So we get these two answers here. Now, it's really not two, it's 4 answers, right? We have positive 3, negative 3, positive square root of 3, negative square root of 3. Okay, here's another example. This one looks scarier, but in a way it's easier because the substitution is more obvious, right? It's quadratic-like. If you kind of look at it, this thing is squared, and then we have this thing again to the first power, and then we have this constant term. So it's not even just quadratic-like, it is quadratic the way it's set up right now, but having this fraction in the parentheses is kind of scary looking, so we can make it look a little nicer by substitution. Let's replace the b minus 5 over 6 with a w. We'll make the same choice here, right? So we need to be consistent and do the same thing. W can only take the place of b minus 5 over 6. That's the only thing it's allowed to replace. Thankfully, that's exactly the same thing that I have here. So I'm going to let w replace that expression here as well. In this case, it's getting squared. So I'm going to copy down that power of 2. We have the minus sign here. We have the minus 6 equals 0. Now it's quadratic. Now it's familiar looking. It looks just like how we imagine, I don't know how I want to say this. It is a quadratic equation, right? So let's solve it as a quadratic equation by factoring. And again, we'll do the same thing we did in the last one, even though the number here is kind of hidden from us. We want two numbers that multiply to negative 6, add to negative 1. Those two numbers will be negative 3 and positive 2. All right. And then we solve by setting each factor equal to 0. And if you'll permit me, most students kind of jump to the conclusion here. And so I'm going to do the same thing. This ultimately is going to give me that w is equal to 3. This is going to give me that w is equal to negative 2. Now that we're done with w, we need to unsubstitute. We want to take the w back out of the problem and put back in the b minus 5 over 6. So we're going to put b minus 5 over 6 here in place of the w, and b minus 5 over 6 here in place of the w. All right. And now we have to solve for b. So it's a fraction. First thing I'm going to want to do is get rid of the fraction, multiplying the common denominator to both sides, which is 6. Those 6's cancel out. And so we end up with, I'm going to continue over here. I think I have enough room to do this. We'll end up with b minus 5 equals 18. And then we'll add 5 to both sides to solve it for b. And we get b is equal to 23. We'll do the same thing here. Multiply 6 to both sides. Maybe I'll just use a different color so it stands out a little bit better. Multiply 6 over here as well. Here the 6's cancel out. And again, I'll get b minus 5, but this time I'm going to get negative 12. Right? So b minus 5 equals negative 12. Add 5 to both sides, and we get b is equal to negative 7. So my two solutions are 23 and negative 7.